So this question asks us to examine these four equations and determine their symmetries. Is this first equation symmetric with respect to the x-axis, symmetric with respect to the y-axis, symmetric with respect to the origin, or neither? So we have x squared plus 7y equals 9. Let's write that down. And how are we going to analyze this? Well, I want to replace either x with negative x or y with negative y, or possibly both. And which one do I think will lead me to the same equation? Well, the even power on x gives me the hint. I'm going to replace x with negative x, because we know negative x squared is the same as x squared. And I get x squared plus 7y is 9. That is the same equation. Well, if x and negative x behave the same way, if here's x and there's negative x and they behave the same way, that tells you what your symmetry is going to have to be. This is going to be symmetric with respect to the y-axis. So the y-axis should act as a mirror. So if we look at the graph of this, so let us go to Desmos and see. We're going to graph x squared plus 7y equals 9. And sure enough, it looks like the y-axis is acting as a mirror. So that is symmetric with respect to the y-axis because I replaced x with negative x and have the same equation. All right, next up, we have y to the fourth minus xy squared equals 9 again. Y to the fourth minus xy squared equals 9. And this time, I'm going to replace y with negative y and see what happens. X has an odd power, so x to the first and negative x to the first are different. I know that. So let's try to replace y with negative y and see what we get. Negative y to the fourth minus x times negative y squared equals 9. Negative y to the fourth, negative, 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 negative makes that positive y to the fourth minus x, negative y squared equals 9. Same equation. If I replace y with negative y, right, there's y and negative y behaving the same way. What is my symmetry going to be? That should be symmetric with respect to the x-axis. So let's look at Desmos and see if that's the case. So y to the fourth minus xy squared equals 9. An interesting looking graph, I guess. We can zoom it out and see if we see any changes in the behavior. Not really, but you can see that this point here is paired with this point here. They're essentially the same, right? So we have mirror images across the x-axis. So indeed, this is a symmetric with respect to the x-axis equation. What do we have next? We have x squared over 25 plus y squared over 49 equals 1. X squared over 25 plus y squared over 49 equals 1. What you will notice here, I can replace x with negative x, it'll work. Replace y with negative y, it'll work. Replace them both and it'll work, right? So replace x with negative x. We'll take a look at that. So here we go. Replace x with negative x. That gives me x squared over 25 plus y squared over 49 equals 1. That's the same. So if x and negative x are the same, that's symmetric with respect to the y-axis. Now if I replace y, so leave my original one alone, replace y with negative y. x squared over 25 plus negative y squared over 49 equals 1. That will give me x squared over 25 plus y squared over 49 equals 1. If y and negative y are the same, it'll be symmetric with respect to the x-axis. How about I replace them both, right? Replace both x with negative x and y with negative y. That's how we check to see if it's symmetric with respect to the origin. That gives me negative x squared over 25 plus negative y squared over 49 equals 1, which becomes x squared over 25 plus y squared over 49 equals 1. Again, that's the same. Replace x with negative x and y with negative y. That's the same. So that is symmetric with respect to the origin. So that has a whole bunch of symmetries that we can work with. So let's go ahead and graph that. And you'll see that lots of mirrors here. X squared over 25 plus y squared over 49 equals 1, sure enough. The x-axis is a mirror, symmetric with respect to the x-axis. The y-axis is a mirror, symmetric with respect to the y-axis. If you fold it twice, they match up, symmetric with respect to the origin. All right, our next question is 3x plus 2y equals 9. So let's write that down. And I'm going to see what happens as I do that stuff. 3x plus 2y equals 9. Replace x with negative x. I get 3 times negative x plus 2y is 9, negative 3x plus 2y is 9, not the same. Replace y with negative y, 3x plus 2 times negative y is 9. 3x minus 2y is 9, not the same as 3x plus 2y equals 9. If I replace them both, so replace x with negative x, not the same, so it is not symmetric with respect to the y-axis. Replace y with negative y, not the same, so it's not symmetric with respect to x-axis. Replace them both. 3 times negative x plus 2 times negative y is 9, gives me negative 3x minus 2y equals 9. Still not the same as 3x plus 2y equals 9. Not the same. So it's not symmetric with respect to the origin. So yeah, that's neither, right? We have no symmetries there. We can look at our graph, 3x plus 2y equals 9. 3x plus 2y equals 9. And sure enough, x-axis is not a mirror, y-axis is not a mirror. If I fold twice, I don't get things matching up. Let's go ahead and add one more question here. So I put on xy cubed equals 7 because I want to show another example. If xy cubed equals 7, what's going to happen? If I first try to replace x with negative x, negative xy cubed equals 7, negative xy cubed equals 7. So no, not the same. So it is not symmetric with respect to the y-axis. I replace y with negative y, so x negative y cubed equals 7, which gives me x negative y cubed equals 7, which gives me negative xy cubed equals 7, not the same. So that is not symmetric with respect to the x-axis. Now let's go ahead and replace them both. Okay, replacing them both, I get negative x times negative y cubed. Does that equal 7? Well, that's negative x times negative y cubed, because negative, negative, negative stays negative, equals 7. So I get xy cubed equals 7. That is the same. So if that's the case, this is symmetric with respect to the origin. So let's go to our original question there, xy cubed is 7, and look at its graph on Desmos and see if we see the double flip, right? The double mirror kind of argument. Xy cubed equals 7 on Desmos. And we should see that, I hope. Xy cubed equals 7, and boom, double. Fold it along the x-axis and then along the y-axis, and it matches. So indeed, that one is symmetric with respect to the origin.